Hi, my name is Ben Stern. I'm going to talk to you today about IBM's service management solutions and how we can help you when you're going through your digital transformation. How do you manage and monitor your hybrid applications that span complex environments, leveraging some cloud native services running in IBM Cloud Private?
Okay.
All right, there you go. So you see on the screen a topology of the business application. As I mentioned, it's running inside of IBM Cloud Private. And we're going to help you manage this overall environment, leveraging a lot of machine learning and analytics to help reduce the noise, help you detect some problems early to potentially avoid outages and slowdowns in your business applications. So like most organizations, I don't like to stare in front of a screen looking at an event list. I want to get notified via my choice, in this case, Slack notification, but this could be SMS messaging, voicemail, email. I get a notification saying I've got an issue on one of my database servers with some response time, and I'm going to select the link and drill into that particular problem with a launching context. Potentially I could run a runbook to fix the problem immediately, but I want to go investigate. So I've got an event list. A couple of things that are important here. We're leveraging analytics and machine learning to automatically group these events. So instead of seeing 4 events on the screen, you're seeing 1, and it's reduced some of the noise and complexity in the environment. But there are multiple events here, and we can expand the list and take a look. The other thing we've done is we've leveraged analytics to do early detection of these problems. We do predictive analytics on the metric data as it streams through the system, detecting the abnormal patterns in the behavior of the data. We detected a topology of the business application. In this case, it's a set of microservices running inside of IBM Cloud Private, and the nodes that are affected by these particular anomalies are shown at the bottom of the screen. Now, I could potentially fix this problem now based on this set of warning alerts. And you can see that the nodes are affected. These are the events that are affecting that particular database node in this particular environment. But let's say it's a warning, I'm busy, I don't want to deal with this right now, and I wait a little while. Some amount of time later, an additional event comes in. And in this case, it's actually a group of events. Again, the analytics applied to the data automatically group this set of related events that span multiple servers in the environment. Severity is now critical, so things are starting to look a little bit worse. Static thresholds have been detected, and applied analytics group them together. Again, I can see a little more data about what's happening in the environment. I've got some slow response time in the application. I've got some problems with lock wait times on the database, and I've also got a potential problem with the disk that's the storage volume for that particular database server. You see that reflected in the topology, and I'm going to leverage some of the key capabilities of this topology to help see what's happening. One of the key things you see in environments is that change oftentimes introduces the problems that we see. And in this case, I'm going to go back in time just before this particular problem happened and see whether or not there were topology changes that occurred in this particular environment. In this case, you can see that a database node was added on a virtual machine, but you also see a containerized version of DB2 got deleted. So the little minus sign and plus sign on those particular elements in the topology indicate whether or not they were added or deleted. So somebody made a change to the business application. They removed the database on the container, added it on a virtual machine. This is actually a fairly common practice as you move from development to production, to move that database to a virtual machine, potentially a physical server, to add more capacity. We can look at the response time of the application. You can see that it's actually increased to a little over 2 seconds. Quite abnormal for this particular application, which usually responds very fast. We can collaborate, talk to the dev team and the ops team, talking about the problem itself. You know, the developer telling me, hey, you know, there's a problem with the response time on this application. And I tell them, yeah, I'm aware of it. My analytics actually detected this about 20 minutes ago. He's also telling me that they moved the database node. Well, you know, my topology showed me that as well, and I'm already aware of that. But it's good for him to tell me, hey, we made the change. I could continue to dialogue with that particular dev person and try to find out why, what other changes they might have made. But the tools told me all this information already. So I can look and see if there's any runbooks available to me to try to potentially fix this problem. These are fully integrated into the tool in context. I can run the runbook. In this case, it's a semi-automated runbook, but it could be fully automated. The idea here is we pass context in. It's got the name of the database server or the IP address. I apply the runbook. In this case, what I want to do is fix the problem. It's a problem on a database server. I've got some lock wait times, problems on the disk. I'm just going to fail this database over to the standby server. We've got all our databases clustered, so I'm going to cause a failover. It's going to fix the problem, hopefully. And this is very common practice, right? We don't necessarily spend a tremendous amount of time investigating. We fix the problem first, and then we go back and investigate the database later, and we go back and see what the root cause was. So the runbook ran successfully. I was able to rank the runbook so that I can know later on whether or not that's a good runbook to use for the future. This one has a 96% success rate, so that's very good. Now you can see in the topology the events were cleared, everything is returning to normal, and that's great. I've fixed the problem. I can go back in and I can look at the monitoring tools and see whether or not the response time has actually been fixed as well. And in this case, the response time is returned to normal, so life is good. I've resolved my application. I've leveraged the analytics for early detection of problems. I've leveraged them to reduce the noise by grouping all of my events to those root cause events, and really leveraging the capabilities of this integrated solution to help me solve this problem in this microservices-based application.